Okay, so next we'll just copy paste our insertion insertion sort code over into our shell sort code. So that shouldn't be too hard because now we really have to just re-implement insertion sort with the gap. Okay, so the loop will now not go from 1 until n, but it's going to go from gap until n, and we'll generate these gaps up here. So here we'll have gaps is equal to, and this will now, for example, be the shell gaps of n. So remember, local variable n, as always, where you're pasting this, or not pasting this, inserting this into the function here. And now we have our gap sequence. And then we can loop through the sequence for gap in gaps. Now I'm going to indent all of the rest. So we are repeating this pattern over and over again. So we're doing insertion sort for each of the different gap sizes within the gap sequence, okay? And down here, when we are making the actual comparisons, we are not comparing with the adjacent neighbors, directly adjacent neighbors, but we are comparing with whatever the current gap size is, okay? So, and then down here, we are copying over not from the direct neighbor and using the gap neighbor instead. Okay, do you say gap neighbor? I don't know if that's a real thing. Anyway, I think this should be it. In terms of the yielding, I'm not sure. We'll talk about colors in just a second. Other than that, I think we should be fine. Let's see whether that works. Just going to test this out down here. So, no, actually, let's do it the right way. Let's go back to animate and add shell sort to our dictionary here. So shell sort, and then we're going to say shell sort. Yep, and here we'll have to type from shell. So that's our new script, shell.py. We're going to import shell sort. Just making sure that I changed the name. No, I did not. So this has to read shell sort. Head back over to our main and let's run this. No, indentation error. So let's go back here. What is the problem? Down here. Yes, I think we have to indent this once more. I think I just copied this incorrectly. So let's try again. Okay. Oh, what is the problem here? Is there any problems? Let's increase the speed. This appears to be working nicely. It's just that the colors are not really helping the eye in terms of, understanding what the algorithm does. We can kind of see that there's always this gap which is shrinking, but there's a lot of flickering here. So let's go back to the script. I don't think we have to highlight instances where we are inserting. We got this idea from insertion sort, and here it was important to highlight that. But with shell sort, what really matters is that we are highlighting the fact that there's a gap between the elements that are being compared. So I think I'm just going to change this to I, or it doesn't really matter. I'm just going to say j minus gap up here. So we have the element I highlighted in one color and j minus the gap in the other color. So let's go back to the main. Let's run this. And now it should be a lot easier to see because we have this yellow bar and then we have a red bar. And throughout the animation, just increase the speed here again, we can see that they are coming closer and closer together. And this is really what, shell sort is about. The yellow bar is the one that's traveling back and forth, but they are now very close together, and the whole thing terminates rather quickly because with shell sort, look at this. We're going to increase this to 500 now. And yeah, let's increase the animation speed. And shell sort will have no trouble at all in sorting this array. Okay, there's a bit of it's kind of like jumping a little, at least it feels like that. So let's see where that comes from. Let's get back over to our shell. I don't think we can fix that, but what we could do is we could unindent this by one tab because this was indented one too many times, I believe. Yeah. So let's run this again. So yeah, this is working. we're not yielding as many times as we had before, and this is why we kind of see this little jump happening. But other than that, I think it's running perfectly fine. The only thing that's left to do now is to play around with the different sequences. And wouldn't it be kind of nice if we could now specify that we didn't always want to use the shell gaps? And the easy way to fix this is to just have an additional argument up here that says which sequence do you want to use. And initially that's shell gaps, but I mean, we just implemented all of these gap sequences, so we want to use these. So we want to be able to use Hibbert and Popernov, Stasevich, and so on. So what we'll do is we'll store all of these different gap sequences in a dictionary, which I'll call gaps dict. And in there, we'll now define shell, which is shell gaps. We'll then have the Hibbert, and this is Hibbert gaps. We then have, I'm just going to call it Popernov because I don't want to be spelling that super long name all the time. Could have used a shorter name before, I know. Then we have Knuth. Then after that comes Tokuda. Well, Tokuda with gaps included. That's the function name. This comes now. Next is Sedgwick. And then finally we have Giura. So Giura gaps. And yeah, I think this is it. And the only thing left to do here is not always use shell gaps here, but we'll use our dictionary. And then from this dictionary, we are going to get whatever sequence the user specified up here. And let me just highlight the fact that in our animate script, in our animate function, we had this quarks thingy, which enabled us to pass additional parameters to our function, right? So we can now specify sequence. I mean, animate did not know about anything that's called sequence, right? It just says n, speed, width, and height. There is no sequence here. But this is this quarks thing. So this is saying, if you're defining a new thing later on, which we are doing here in shell, we are now defining in shell sort, we are now defining sequence, then you can still use that, even though it has not been explicitly defined within animate, within the animate function. Yeah, let's see whether that works. So let's use Hibbert instead of shell sort with the shell sequence. Unfortunately, it's not working, because I guess I messed up something in my dictionary. Let's go back over here. This is not working. Why is that the case? Very simple. I forgot to insert n, right? All these functions up here, they have to have this n. So let's try this again. Go back to the main, run this once more, and now it's working. So I'm going to close this just for the moment. This get function here is really just taking whatever string we're passing into it, and then it's getting this from the dictionary. But since these are functions that are stored within this dictionary, we still have to specify the parameter of these functions, which was n. Otherwise, the sequence will not know how long it's going to be, okay? So let's go back here, and I'm going to increase the speed. Okay, so let's set this to 100. And now we can see how shell sort is just sorting this so quickly, okay? This is now using the Hibbert sequence. And instead of the Hibbert sequence, we might want to use the Giura sequence. Remember, we weren't really sure whether the Giura sequence was actually working because we didn't really make sure of the length of the array. So if we go back here, we didn't really make sure that this n had anything to do with the length of this hard-coded sequence. So let's see whether we can use the Giura sequence here. I'm going to run this, and yeah, this appears to be working, no problem. So let's see whether we can use a shorter array, a smaller array of just 50 elements. And yeah, no problem. This is sorted within, just a couple of seconds. And yeah, I think this is it for this video. If you're really, we could just set this to like 200 and then play this once more. This still shouldn't take too long because you're noticing that these algorithms are now getting more and more powerful. Bubble sort would have taken a very long time to sort this array. We can just run it to compare it, but you'll notice this is just 5 or 6 iterations of this loop. Look at it now. I think it's already on the very last one. And yep, it's sorted. And with bubble sort, just to compare this, let's try bubble sort. We don't have to have this geoda sequence here. Yeah, it's running fast because we set a high speed up here, but I mean, come on, this is now hundreds of loops that we have to go through until every element is sorted, and we'd be sitting and waiting a long time until this blue section of the array has grown all the way over there, or will have grown all the way over here. Anyway, we have just implemented shell sort. It's pretty powerful, actually. And yeah, I think this is it for this video. Thank you for watching. See you in the next one.